This video is about how I installed OpenWRT on an obscure cable modem and issues around firmware hacking in general. So someone was giving away this sort of cable modem router wireless thing, which, I guess would be like, your home provider's solution for your house. And this is one of the ones that's known to have some glitches. And I don't know if putting OpenWRT on it fixes these glitches or not. I guess time will tell. But I do have other stuff that I use myself, so at this point I didn't really need it. I confused it with another model and thought it was supported by OpenWRT, but it wasn't. So I kept checking in, and eventually somebody did start working on it. So now it's in a working state. So the traditional and easiest scenario is where you log into whatever device, and there's a firmware update part. You select a file, and it updates. In OpenWRT, there's usually two different files. One is for upgrading an OpenWRT system. The other one is a file that's kind of designed to trick your original thing into thinking it's what it needs, but that's called the factory one, so you only use that once. At a medium difficulty level, there's some sort of serial header, TTL serial, on a board that is designed with features that allow you to take control and potentially reprogram a device. At a harder level, you would have to connect like a SPI interface to the board and flash it through the board, or you could desolder it and do the same thing. At a very hard level, you may have to exchange keys with a flash chip, and then at that point it's getting too hard. So luckily I have some microcontrollers here, and some of them can be used for an inline TTL converter because they have a chip on there which bridges USB to serial, which ultimately is accepted to control the microprocessor. In this case, the enable pin is shorted to ground to disable the chip so it's not interfering with the process. This was a setup. That's like a Raspberry Pi that's isolated electrically, going through wireless. It's going to a microcontroller acting as a TTL converter connected into the serial header there. And what we're doing here is loading the kernel into memory and then running off of a USB stick there so that I can overwrite the flash of the router, and then you can disconnect everything and it'll be running properly. So I did this in parts so I could make a really good video capture of the screen when I was running terminal. So there is some sort of initial software that's interactive. So it's a console, but it intends to be interactive. So you get to a point and you can press a key, and then there's a menu. And the menu allows you to do a few different things. One of them is load some arbitrary thing into memory. It can be from ymodem. In this case, it was from ymodem. There's some other things that I think you can do, but I didn't do it. So this is the only time that I used ymodem to put anything into memory, because once the kernel got executed, I changed the partitioning of the flash. I copied the kernel to one of the flash partitions, and it was there. So in further times than I did this, I would go back and I would load from the flash instead of ymodeming it, which took about 10 minutes or so. And I did have tribulations and whatnot, because it turned out the image I made didn't fit on the root partition, and I had confusions over squash. And I had eventually, I went back and I changed the size of the image it made, and it was very close, but it did work. I still totally understand it, but my understanding is that it somehow reclaims the space that it's like it writes into the partition like it's uncompressed, and it compresses, and then it's like mostly empty, and then it reclaims the empty space. That's the best thing I can figure out. And it's very kind of strange, but I think that's how it works. And you do wind up with a lot of space when you're using a squash FS, and it's definitely what you want to do, is use compressed software. It leaves you with more room for yourself. I guess I should mention that the actual cable modem itself is, I don't think, supported by this, but I personally don't use it. And what I use is a smartphone USB tether, which I'll be demonstrating later in this video. So I'm at this Santiago on the OpenWRT forum, and he appears to be the author of this entry into the OpenWRT scheme. So what he did is he put together a set of configurations and whatever files you need to locally build the OpenWRT project, and then it kind of exists there and not on the main server at this time. But it is a target, the intelce target. And Santiago was just so helpful, and he knew so much about everything that we needed to do this. So this is a list of the built-in shell commands. It turned out that I also had to modify sort of like a startup script that involved loading one of the partitions, some data off one of the partitions, and then booting that data, the Linux kernel, as well as setting some GPIOs and other things. This is my first test of using the Interactor shell to get a PCI device list, and there's a very large amount of devices there, and a lot of times OpenWRT does not ideally implement all the hardware acceleration, and I'm sure that's the case here. So this was the prescribed partition table, and the original one had like 10 partitions. The entire flash drive was, for flash unit, was backed up to a file, as well as partition 6, which included the wireless configuration data or something to this effect. 6 was moved to 2, hopefully still recognized by the system. I'm told that hopefully it still is. And what's important to know is you don't delete the first one, because the free space there, 248 to 4607, is actually the Interactor shell, and without that you'd probably have to, I don't know what you do to get it there. So it's really critical to leave that in, and just increase the size of 1, I believe, from, I don't know, 4 to 8. So this is after I closed it up and I was just sort of exploring around to see how, if it was all functional. I started to sort of back up the build files over there, but I don't think I'll ever use them, and in that case I decided to make clean do that again. Okay, so we're just sorry, I have a cold. We're just testing out the smartphone application of this. This is one of the main points of this. And this is, again, to share it to a whole network, not just your computer. It works in a way that's similar to USB tethering. So in this case, the Apple phone is connected by a USB cable to a USB port. There's one, you could put a hub on there and share that USB port to multiple devices. But what's happening is going into that modem there is being it's being network address translated, shared between various things, and going into my computer there. And so now through those devices I can play this back. Turn it to HD here. There we go.
These other connections, those red connectors are for kind of boards, and if I want to use them, like.
So what happens there is when you install the driver for the Apple stuff, you get this new network device, whatever it is. This is the next one, ETH1 here, and I configured it as a DHP client, which it connects, gets a number, and your internal number is different from that number. Your major numbers are different. So not every router will allow you to do this, but in this case, OpenWRT, I've configured this as a client of my other router's network that goes actually on my cell phone. So you could use this to, for example, share your internet connection if your computer that didn't have a network adapter. This is a very solid network receiver, right? But there's that particular router, right? So it's actually coming from that router, which is coming from that phone. But here it is on my own. It's bridged to my own network here, and so where's yeah. Okay, that's the connection to my main router, where it's acting as a client. And I put both. I couldn't do things until I made it zone LAN, which I was a little afraid, but technically those are two tap offs of the LAN segment. So here I can SSH to it. I'm just going to tell it to halt, which it will immediately, yeah, it doesn't really halt very gracefully. It doesn't halt very gracefully from the Wi-Fi, but it does from the usually Ethernet. So see, I don't know what that light's doing here, but it did halt. So here we go. I always halt it. So here's a photo of my particular hardware, and I think there are a few different revisions. So this is somebody's picture of their hardware, which is a different revision. You can see the PUMA CPU without the heatsink. The PUMA CPU is quite formidable at 1200 megahertz by 2 cores, making it actually more powerful than my computer I was using in 2000 by probably 2 times, but it lacks the the peripheral support, the video support, whatever. It also has an ARM core, which I think this build does not use. Thanks for watching.